Hello, welcome back once again. I gave this definite integral a name. And what's the name? The innocent looking integral, right? This integral looks very cool, but I will tell you the truth, it's a very stubborn one. So let's see how we're going to tackle this integral in this video, okay? So remember we have the integral from 0 to pi of x divided by 1 plus the sine function of x dx. So we're going to start with the following substitution. So we're going to call this integral I first. Then after doing that, then we make the following substitution. So we're going to let x equals pi minus u. Well, we call it the King's property, right? Okay, so here we also know that to solve for u, this also implies that u is equal to pi minus x. So we differentiate both sides here, we get dx is equal to negative du. So our I is going to be equal to the integral. So let's check the limits of integration. Now when x is approaching 0, u is approaching pi minus 0, which is pi. When x is approaching pi, u is approaching pi minus pi, which is 0. So here x up there will be pi minus u. Did I get it right? Yes, cool. Then divided by 1 plus the sine of x, which will be the sine of pi minus u. And then our dx will be negative du. Okay. Now there is a nice property we're going to take note of here. We know that the integral from a to b of f of x dx, that is equal to the negative, then we switch the limits from b to a of the same function of x dx, right? So using this property now, our I is going to be the integral from 0 to pi now, right? So we're going to have here pi minus u, then divided by, so 1 plus, we know that the sine of that angle is the sine of u, right? And then we have our du, no negative sign again, right? Then the next thing to do here is to split the denominator. So by splitting the denominator, we have I will be equal to the integral from 0 to pi. So we're going to have here pi all over, so 1 plus, so sine of u is same as sine of x. Remember that u is a dummy variable. Then the x, so minus the integral from 0 to pi. Then we're going to have u up here, which is same as x, divided by 1 plus sine of x. And then we have our dx. Did you realize something? This right over here is our I. Therefore, if you add I to both sides of this equation, so add I to both sides, so we're going to have 2I will be equal to pi multiplied by the integral from 0 to pi. So we're going to have 1 over 1 plus the sine of x, and then we have our dx. Is that all? No, we're just starting. That's why I call it the innocent looking integral. So from here, we're going to make use of the Weierstrass substitution. So we're going to let x equals 2 multiplied by the inverse tangent of y. So differentiate both sides, we get dx will be equal to, this will be 2 all over 1 plus y squared, and then we have our dy. Okay, this is really cool, right? So this is the Weierstrass substitution. Now, according to Weierstrass, well, we can still prove it using the right angle triangle. So we have that the sine, of 2 times the inverse tangent of y, this will be equal to 2y divided by 1 plus y squared. Okay. Now we have here 2I will be equal to the integral from, we're going to have enough space from there. So let's erase that and scroll down. Okay. So we're going to have 2I is equal to, that is pi, multiplied by the integral from 0. Oh, wait, we're going to check our new limits. Okay. So from here, we actually know that if you divide both sides by 2 and take the tangent of both sides, we get y is equal to the tangent of x over 2, right? So now, if x is approaching 0, y is approaching the tangent of 0, which is 0. If x is approaching pi, y is approaching the tangent of pi over 2, which is infinity. And here we're going to have 1 all over, so this will be 1 plus the sine of 2 arctangent of y, that will give us 2y over 1 plus y squared, right? Then multiply by dx. Is that our dx? Yes, okay. So our dx is equal to 2 divided by 1 plus y squared. So we have 2 divided by 1 plus y squared, and then we have our dy. So here 2I is equal to, this is pi, the integral from 0 to infinity. Oh, the 2 is going outside, right? So we're going to multiply this numerator throughout here. We're going to open that bracket with 1 plus y squared. So we're going to have 1 all over. So 1 times 1 plus y squared will give us 1 plus y squared plus, then this one, 2y over 1 plus y squared times 1 plus y squared. 1 plus y squared we cancel. Then we're going to have here 2y. And then we have our dy. Now divide both sides by 2. We see that our I is equal to pi times the integral from 0 to infinity. So this is going to be 1 over. So this is a perfect square, right? So it is y plus 1 whole squared, and then we have our dy. Okay, this is really cool. So let's make the following substitution. So we're going to let 1 plus y equals x. Differentiate both sides, we get dy is equal to dx. So you know our limit is going to change. So our limit will be from, we have pi times, you know, if y is approaching 0, x is approaching 1 plus 0, which is 1. If y is approaching infinity, x is approaching 1 plus infinity, which is infinity. Then we have 1 over x squared, and we have dx. So this is equal to pi times the integral from 1 to infinity. So this is going to be x raised to the power of negative 2, and then we have our dx. So here, this is really cool from here and easy enough, right? So this is going to be pi, then into bracket. So we use that power rule. So we're going to have x raised to the power of negative 2 plus 1 divided by negative 2 plus 1 from 1 to infinity. So this is going to be pi. So it's going to be x raised to the power of negative 1 divided by negative 1, which is same as negative 1 times x to the power of negative 1. Sorry for this. So we're going to have our limit from 1 to infinity. So here we're going to have this equal to, simplifying that nicely, we take this as negative 1 over x, right? And then from 1 to infinity. So this is going to be equal to pi into bracket. So if you substitute infinity, we get negative 1 over infinity. Then minus, put 1, we get negative 1 over 1, right? Okay. So here we get I is equal to, that will be pi into bracket. Negative 1 over infinity will give us negative 1, 1 over infinity right over there is 0. We know that will give us your 0. So minus 1 will be plus 1. And here we get our solution, pi. Were you thinking that pi will be the correct answer? This integral is really cool. Thank you for watching. Please support this channel by subscribing. Also like, comment, and share.